Okay, so we're ready to start the next section, section 6.3, and we're going to talk about solving trig equations. So before we actually get to an equation that we're going to solve, I want to review a couple of things with you. All right, so first of all, this is our circle. We talked about this at the beginning of the year with all of our angles labeled in radians. All right, so I'm going to ask you two questions when we look at this circle. All right, so first of all, I want to know what angles have a sine value of 1/2. Okay, so in other words, I want to know where is sine theta equal to positive 1/2. So a couple of things come into play when we go to answer that. First of all, I have to remember my positive negative sign chart for this particular function. So I have to remember that in the first quadrant we're positive, in the second quadrant we're positive, the third quadrant we're negative, the fourth quadrant we're negative. Okay, so that's the chart for the sine function. So then I have to remember my memorized value, which most of us know that sine at pi over 6 at 30 degrees is where we're getting a value of 1/2. Okay, and I think that's pretty safe to say that we all have that one pretty well memorized. Okay, so we know that sine pi over 6, so that's this angle right here, has a value of 1/2. Now, there also will be a value in the second quadrant, or an angle in the second quadrant that has a value of 1/2. And so we've talked in class a little bit about mirroring an angle over into another quadrant. So if I take this angle, this pi over 6, and I flip it over the y-axis, it's going to flip right here. And so that's going to be the mirror angle for pi over 6. And so since we have the positive right here, we know that sine is also equal to positive 1/2 at that mirrored angle, which is 5 pi over 6. Okay, so note that we have two solutions to sine equaling 1/2. Okay, as long as we're looking at one rotation around this unit circle. All right, so the second question sort of follows up with that, and it says, where does sine equal negative 1/2? All right, so this time I'm looking for angles where the sine function is equal to negative 1/2. And again, we know that it's based on that pi over 6 in the first quadrant, okay? It's based on this angle right here, but we're going to need to mirror it into the third and the fourth quadrants because that's where we have the negatives. So if I mirror this pi over 6 angle down into the fourth quadrant, we're here. And that is at 11 pi over 6. So that's a solution. And then if I take that and in this case I'm going to probably take this line right here and mirror it over into the third quadrant. So it's going to flip over right here. All right, and so that would be 7 pi over 6. All right, so I want you to kind of keep that in mind as we go forward in this section. First of all, that very often when you're solving an equation for a particular value, you're going to have more than one answer, okay? Because for each of the trig functions, they are positive in 2 quadrants and negative in 2 quadrants. So in a lot of cases, you're going to have 2 answers coming out of these equations that we're going to be solving. All right, and then the second thing I want you to keep in mind is that it all builds from that memorized value that we have in the first quadrant. Like in this case, we had to get that pi over 6 first in order to figure out the other 3. Okay? All right, so The next thing I want to review with you really quickly is solving an equation in algebra. All right, so if you have the equation 2x minus 3 is equal to 2, and we all know how to solve this, but I just want to walk you through it. Remember, your goal is to get the x by itself. So you would look at this, and the first thing you would do is you would subtract the 3 off from both sides of the equation. And so this is going to cancel. You're going to be left with the 2x on the left. 2 minus 3 is a negative 1. And then from there, you're going to divide both sides by 2. And again, the 2's will cancel, and your solution would be x is equal to negative 1/2. Now, if you notice in the trig equation underneath, it is almost identical, except that instead of having an x, we have a sine theta. Okay? And all that means is we're using kind of like a different variable. So instead of an x for our function, we have a sine theta for our variable. The process of what I want to do is exactly the same. So the first thing I want to do is subtract the 3, because my goal is to get that variable, that sine theta, by itself. So we'll do exactly what we did in the algebra equation. The 3's will cancel. We'll be left with 2 sine theta. And then again, 2 minus 3 is negative 1. The next thing I'm going to do is divide both sides by 2, just like I did in the algebra equation. The 2's will cancel. We'll have sine theta is equal to negative 1/2. And in an algebra equation, we're done at that point, right? So like here, that was all we had to do, and we said that's our answer. In the trig function, we have to go one more step, and we have to actually find the angles that make that true. All right, so I'm going to go back to what we just talked about. We've already answered this question, where is sine equal to negative 1/2? And so we know that we have two answers. We have 11 pi over 6 and 7 pi over 6. All right, so I'm going to come back to my equation, and that is going to be my final answer to this trig problem. We're going to say that theta is equal to 11 pi over 6 or 7 pi over 6. Okay, so as we get started on these, what you want to remember is that you're basically going to solve them just like you would solve it if your function was an x, just like you would do in an algebra class. And then at the end, you're going to go one more step, and you're going to find the angles that make your equation true. All right, so let's go through some examples. All right, your directions are going to tell you to solve on the interval from 0 to 2 pi, which basically just means that you are limited to one rotation of that unit circle. You don't have to worry about going all the way around and then going to another angle, that you are limited to just answers between 0 and 2 pi. Okay, so this kind of simplifies things for us. All right, so let's look at this problem. So if you ever get stuck, put an x in place of the function and think about what you would do if your problem had looked like this in algebra. Okay? And so I would probably look at this and say, well, I would subtract the 1 first. All right, so I'm going to do that. I'm going to come over here. I'm going to subtract 1 from both sides. All right, so that's going to give me a negative cosine theta. And then 1/2 minus 1, you can use your calculator if you need to. That's going to be a negative 1/2. Okay, and we're almost there. The only thing is we have to have cosine by itself. We can't have a negative in front of that cosine. So you either need to multiply both things by -1, or you need to divide by -1. However you want to look at this. I tend to multiply, so I would take this entire expression and multiply it by -1, which essentially just changes my signs. All right, so now I have cosine theta is equal to positive 1/2. So remember that we expect there to be two quadrants where we have an answer to this. Okay, so think about your sign chart. on your cosine. So we have positive, positive, negative, negative. So I'm expecting an answer in this quadrant and also this quadrant because our cosine value is positive 1/2. All right, so let's go ahead and figure out the memorized value. So where in your first quadrant is cosine equal to 1/2? So that would be at pi over 3. Okay, so that's going to take care of the first quadrant. And so what I might want to do here is kind of real quickly sketch that pi over 3. All right, so pi over 3 is like 60 degrees, so it's going to be here. And then I know I also need it in the fourth quadrant, so I can sort of mirror it down. All right, and then I can look at what that angle is. And so we've talked in class a lot about counting out these angles and being able to determine what the angles are. You're going with pi over 6, so this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. So this line is 10 pi over 6, which would reduce to 5 pi over 3. Okay. All right, so let's keep going. We're going to look at just a few examples so that you're sure that you have this down before we stop with this. Okay, so our next one says solve tangent theta plus 1 is equal to 0. So again, isolating your variable, your tangent, would require that we just subtract the 1. So that part's fairly easy. So we're going to have tangent theta is equal to -1. So first of all, I'm going to think about where tangent is equal to a negative value. And we know that that happens in the second quadrant and in the fourth quadrant. Okay, so I need those two answers, a quadrant 2 answer and a quadrant 4 answer. Okay, so in order to find it, I want to think about my quadrant 1 answer. So that would be where tangent is equal to 1. So I know as a memorized value that tangent is equal to 1 at pi over 4. And that's the angle that comes straight up the middle. Now remember, you want quadrant 2. So I'm going to mirror this over. I also want quadrant 4. So I'm going to take this right here and flip it down. All right, so let's figure out what our angles are. So remember, we're starting with pi over 4, and we count. So this is pi over 4, 2 pi over 4, 3 pi over 4. So that's one of them, 3 pi over 4. And then this is 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. And so now we have our two solutions. All right, what about this one? Okay, you can see that they're getting a little bit harder as we go. All right, 3 on the square root of 2 cosine theta plus 2 is equal to -1. So again, treat it like the cosine is an x. And what would you have done first if you were solving this equation in an algebra class? So we would subtract the 2 from both sides. So that's going to leave me 3 on the square root of 2 cosine theta is equal to -3. And then trying to get the cosine by itself, I would need to divide both sides by 3 on the square root of 2. Right, that would cause it to cancel over here. And then the 3's would also cancel on this side, leaving me -1 over the square root of 2. Now, you probably want to rationalize that denominator so that it looks like something you're used to seeing. So if I multiply top and bottom by square root of 2, I'm going to have cosine theta is equal to negative square root of 2. And then on the bottom, square root of 2 times square root of 2 is just going to be 2. All right, so now we're ready to think about our cosine sine chart. So because my value is negative square root of 2 over 2, I can see that I'm going to need a second quadrant answer and a third quadrant answer. All right, so let's find them, and remember that we're going to find them by thinking about where it is in the first quadrant. So where is cosine equal to square root of 2 over 2 in the first quadrant? So that's your 45-degree angle, or your pi over 4. So again, that's that one that comes right up the middle. Okay, so that's pi over 4. I need it to be in the second quadrant, so I'm going to mirror it over here. I also need it to be in the third, so I'll do the third on the diagonal as well. All right, and then let's find it. All right, so we're going to count it around. So pi over 4, 2 pi over 4, 3 pi over 4. So one of my answers is 3 pi over 4. Four pi over 4, 5 pi over 4. So the other one is 5 pi over 4. Okay, so this is the other type of problem that we're going to see for right now. This would be a problem where we have a squared in it. Okay, this would be the equivalent in an algebra class of you solving 2x squared minus 1 equals 0. And so remember that you would probably add 1 to both sides. You would divide both sides by 2. And then you would take the square root to solve for x. Okay, so we're going to do the same thing here. Okay, same exact steps. So I'm going to add 1 to both sides. So this is going to give me 2 sine squared theta is equal to 1. I'm then going to divide both sides by 2. So my 2's will cancel out. I have sine squared theta is equal to 1/2. And then I'm going to take the square root of both sides because I want to get a sine and not a sine squared. Okay, so let's look at the square root of 1/2. So I know that if I take the square root of a number, it's plus or minus. And this is critically important that you remember that because it's going to help you in getting all of your answers. Let's take the square root of the top and the bottom separately. So the square root of 1 is just 1. The square root of 2 I can't do. So I'm going to leave it the square root of 2. And then I'm going to rationalize. So I'm going to multiply top and bottom by square root of 2. So we want places where the sine value is either equal to a positive or a negative square root of 2 over 2. All right, so think about your sine chart for your sine. And if I want positives or negatives, then I'm going to have 4 answers because I'm going to have an answer in each quadrant. All right, so let's find the first quadrant answer, and then we'll go from there. So where's sine equal to square root of 2 over 2? So again, that is your 45 degrees, or your pi over 4. And now what I'm going to do is mirror that around in each of the 4 quadrants. Okay, try to get it lined up a little bit better there. All right, and so let's go through and label what they are. So we know that the first one is pi over 4. And as you do some of these problems, you'll start to kind of remember the pattern on the answers. All right, so I know that this one is pi over 4. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4, 5 pi over 4. Then 6 pi over 4 and 7 pi over 4. All right, so for this particular problem, mainly because we have the square, then we know that we have 4 answers to this particular problem. All right, so that completes what I'm going to do right here. This is kind of an introduction to solving an equation that involves a trig function.